So, in saying that it's much quicker with the elimination method. All right, so solving a system of equations by elimination is very simple. Conceptually, carrying out the process, not always. But what we want to do is eliminate a variable, eliminate one variable. Through addition. And solve for the other. All right. Sometimes it's called the addition method. Sometimes it's called the addition/elimination method. But really, ultimately, what we're trying to do is eliminate a variable, so it makes the most sense to call it the elimination method. All right. So what I want to do is add two equations together so that I can cancel one of the variables. All right. Now, sometimes the equation is not set up nicely so that you can just add them together. In fact, if I were to add these two equations together, I'd get 2x plus 1x, which is 3x, 1y minus 3y, or plus negative 3y, which would be negative 2y. Nothing's going to cancel. But what I can do is multiply the first equation by 3. That is not a marker. So if I do that, I'll get 6x plus 3y is equal to 18. The second equation I'm going to leave alone, all right, because what I want to do is I want to create opposites. All right, what I mean by opposites is two coefficients with different signs, one positive, one negative. I could have done it with the x's. What would I have had to multiply the second equation by in order to create opposites? What do we say? Negative 2. Okay, yeah, it's easier if I finish the question before you answer it. So anyway, add the two equations together, and you'll see that the y's cancel out. All right, and so we get 7x equals 7. Divide by the 7, and we get x equals 1. All right. We still have to find the y value, but that was a pretty easy way to figure out the x. Now, fun fact, that technique that I showed you, the RREF in the calculator, that's what it's doing. It's performing these operations, but only on the coefficients and eliminating variables. Right? That's why when you look at the coefficients, it's always 1, 0, and 0, 1. It's eliminating the coefficient for y, eliminating the coefficient for x. Right?
How can you multiply just one part of the equation and have the same value?
You can multiply an equation by any number you want as long as you multiply all parts of that equation because it keeps it balanced. Right? It's the same as multiplying the left side and the right side by a particular number. It's the multiplication property of equality. Right? You can always multiply or divide an equation by whatever number you want except for 0 as long as you do it to each part of the equation. Right? So now what I do is what I would do for substitution. I choose the easier of the two equations, or what I perceive to be the easier of the two equations. I plug in the x. So I think the second one's a little bit easier. You might look at the first one and say, I think that one's easier. All right? It's a matter of perception. You can't be wrong. All right? You'd say, well, I don't think that one's easier. I think the other one's easier. So use the other one. Okay? It's as simple as that. I did it this way. Is that okay? Yeah. All right? That's the beauty of this kind of approach. You multiplied the second equation by negative 2. I multiplied by 3. Who's right? We're both right. Okay? So plug in the 1 for x, simplify. Just wait till you get to geometry. When you have questions where maybe there's probably like 20 different correct answers, and then the teacher gives you the answer key, which is their correct answer, and it doesn't look anything like yours, and you're like, how do I know I did it right? That's me not having an answer for you, by the way. Like, but you don't. You just got to trust that you did the process correctly. All right, so divide both sides by -3, you get y equals 4. All right, so just got to represent my answer in the appropriate notation. So xy such that x equals 1, geez Louise, and y equals 4. All right, so that's your elimination method. Now some questions will be a little bit more challenging than others. Yeah, maybe you have to multiply both equations by a number. Maybe you have to multiply an equation by a fractional value. All right. Remember, division is just multiplication involving a fraction. All right. So you're still using the same process, even if you're quote unquote dividing. You're just multiplying by a fraction. All right. So some of these will be a little bit trickier, but they'll all work with elimination. They have to be in the proper format, though. All right, the format is the same as the RREF format, and that is AX plus BY equals C. All right. The reality is they don't technically have to be in that format. It's just more convenient if they are. They have to be in consistent format. Whatever the format is of the first equation, it has to match the second equation. All right. So, but if you get it in AX plus BY equals C, it'll work not only for the elimination method, but it'll work for RREF, and that's your checking mechanism. All right. So I encourage you to try the do now problem again using the elimination method, just to believe me when I say that in some cases it's easier to do than substitution. And then what you're going to do is complete pages 13 to 15. All right. So. And again, no extra help today, because I had it yesterday. All right, so what we want to do process-wise is figure out a way to eliminate a variable through addition. I'm going to add two equations, one to the other. Now, I chose this example because no matter how you slice it, it's going to be a pain to solve for one variable in terms of the other. If I tried to solve for either x or y, it's just a pain, right? You can do it, but it's not something you're looking forward to. And then the substitution makes it very ugly very quick, all right? But what I can do is multiply either of the two equations or both by some number allowing me to cancel out either x or y, all right? So what we need to do first, and it is a matter of choice, tell me which variable you want me to cancel out.
Y.
Y, okay, so y sounds good. So I want to cancel out y. You might have said x. It doesn't matter. You cancel out whatever you want, all right? In order for us to be able to cancel out y, their coefficients need to be exact opposites of one another, all right? So coefficients, so you might want to jot this down. Coefficients must be exact opposite. All right. And it doesn't matter what the numbers are as long as they're opposites of one another. All right? Because you know how, like, when you're adding fractions, you need to get a common denominator? Right? Ideally, it would be the least common denominator. But any denominator that's the same between the two fractions, whether it's simplified or not, will get the job done. It's the same idea here. You're actually looking for, you're kind of pretending that these are denominators or fractions. If you wanted to get a common denominator, you just think, what would you do? All right? So what I would do is multiply, so I have a 2 here. I would multiply each equation by the other equation's coefficient. All right, and that'll get me part of the way there. So I'm going to multiply the first equation by 2. Then I'm going to multiply the second equation by the first equation's coefficient. All right, now that's going to make these values both 6, right? Are they opposites? No. one of them's got to be negative, right? So it doesn't matter which one you make negative, the 2 or the 3, just make one of them negative. So I'll make the 3 negative. I left a little space there.
So you can make any one negative?
And either one, when you multiply by 2 or 3, one of them has to be negative, right? Now, it is possible that they're already negative, or they're already opposites within the equation itself. If that's the case, you wouldn't have to multiply by anything, right? So be on the lookout for something like that, because I've had people say, I want to cancel out x, and it's like, oh, that's cool, but your coefficients for y are 2 and negative 2. I know you want to cancel out x, but be flexible. Cancel out the y's. All right, it'll make your life easier. All right. So, bless you. Multiply through, you get 10x twice.
How do you know what to multiply by?
So again, we multiply by the coefficient in the other. That's why I color coded it.
Oh.
Multiply by the coefficient of the other variable in the other equation. So
So if you were doing x, it would be 4 and 5.
exactly. So 10x plus 6y equals 4. And then for the other one, negative 12x minus 6y is equal to negative 30. All right. So this is getting a little big here, but that's all right. The whole point is that we're canceling out the chosen variable. All right. Add your 2 equations together. Common variable 10 plus negative 12 is going to give me a negative 2x. The y's are going to cancel away. 4 minus 30, 4 plus negative 30, 4 minus 30, negative 26. Then I just solve for x, divide by the negative 2. And I get x equals 13. All right, so that's one of my two answers. I need the y's to go along with it. So then what you do is you go back to your original system, choose what you think is the easier of the 2 equations. They're both pretty ugly here. But the second one has even numbers in it, so maybe I'll just take that one. All right, once you kind of lock on to the elimination method as your approach, it really won't matter what equation you use, because the reason why you chose this technique is because the equations were kind of ugly to begin with. So if you go with the other one, it's perfectly fine too. All right, so I get an x value of 13. I'll just do a little underline there. Pop it in, and get 52 plus 2y is equal to 10. Subtract the 52. So 2y is equal to negative 42. Divide by the 2. So this is all unit 1 stuff, so just kind of breeze through it. You get y equals negative 21. And then you just have to make sure you put your answer in the proper notation. Right? So x and y such that x is equal to 13 and y is equal to negative 21. All right. Now, if your equations are complicated, you're going to have to do algebra. I mean, there's no way around it. But generally, if your equations are in this form, then it's most appropriate to use the elimination method. So if you have a choice in the matter, elimination would be the way to go. So remember the technique of RREF that we learned in the calculator? The structure of your system that you would need to have in order to use RREF is the same as the structure would have to be for elimination method. So it's that form of AX plus BY equals C. So anything in this form, the most appropriate way of doing it is going to be the elimination method. Now, you can decide when the question doesn't tell you specifically which method to use, you can decide which method you want to use on an individual level. But the issue is sometimes you're just going to make your life more difficult. Right? So if I say just solve the system, you might say, well, I'll use substitution. It takes a little bit longer to do it in this case. Right? But I will also remind you, as we get closer to the test, don't forget you have a calculator. right? Because on the multiple choice questions, you do it any way you want. If that means RF, that's fine. You do every single question in the multiple choice using the RF technique, all right? Some people don't like it, but I promise you, after you finish that 10th multiple choice question, you might, if you're using RF, you might not only like it, you're gonna be in love with it, all right? So anyway, so that's your example for addition elimination.